Can you hear me? Just let me know in the chat, please. Okay, brilliant. Brilliant. Okay, good to see you all here today. Right, so today's webinar. So we continue talking about quadratic functions and quadratic equations, of course. And I've got a few problems prepared for you today. Okay. Just the traditional question, how many questions have you managed to solve from the maths? Okay, from maths 19. Okay, 5, 19, 5. So we'll, yes, please do, but you can stay here and we'll still, I think you'll still benefit from this. You can watch the other recordings later on. Okay. All the maths, doing physics first. Okay, yeah, that's fine. So I'd say maths is a bit bigger in terms of the amount of work, but it's on the same time it's simpler. Okay. Physics is a bit harder, but it's fewer questions and yeah, a bit more challenging. Right. I'll share my screen. And the first question, and you'll notice that it's incredibly similar to the one that you have in the assignment. For which values of the parameter a, the vertex of the parabola is 5 units away from the origin? Find the locus of the points drawn by the vertex as a changes. Okay, so what are we trying to achieve? Well, we have a parabola. But it has a parameter. The parameter is a. And well, we know it's an upwards facing parabola. And we need to know where the vertex is. And the vertex has to be 5 units away from the origin. So if we draw a straight line from the origin to that point, that the length should be 5. Okay. Well, first of all, I'd say we find the vertex of the parabola. There are many different ways how to do this. I'm going to use perhaps the simplest way. The vertex of the parabola, the x of the vertex of the parabola is minus b divided by 2a. Therefore, it's well, it's a bit confusing because minus b is a in this case, divided by 2. So that's the x of the vertex of the parabola. To find the y vertex, we substitute x vertex squared minus a x vertex plus 5. In other words, a over 2 squared minus a times a over 2 plus 5. And that's going to be 5 a squared plus a. Okay, I don't want to confuse you. Just don't want to cause extra confusion here. So it's going to be a squared over 4 minus a times a over 2. So that's a squared over 2 plus 5. A squared over 4 minus a squared over 2 is minus a squared over 4. So minus a squared over 4 plus 5. Okay. And we know now this, if this is x vertex, y vertex, and this is 0, 0, 0, 0, we can use the formula for the distance between 2 points. The distance between 2 points on a Cartesian plane, the distance between 2 points is square root x2 minus x1 squared plus y2 minus y1 squared. In other words, it's the Pythagoras theorem, because if this is x vertex and this is y vertex, so in other words, this squared plus this squared is 5. Okay, I'm hoping that makes sense. So the distance is 5, and if we square both sides, it makes 25. So x vertex squared plus y vertex squared is 25. Did I confuse anyone? So let me know, how well do you understand everything so far? On a scale of 1 to 10, please. Anything confusing? Please let me know if you are confused. I would be happy to explain if. Okay. The okay, Anshula, which bit are you confused about? Can you please let me know? And Demir, the y value, like this one. Okay, so you have a parabola. You have a parabola, and this is the equation of the parabola. And we found the x vertex. X vertex is a over 2. X vertex is a over 2. And to get y vertex, we simply substitute x vertex into the equation of the parabola. We substitute it here. Does that make sense? So what we have done, we've just put this into here, and we got this result. Okay. Minus b over 2a. Yeah, that's minus b over 2a is equal to a over 2. And then, so we know that x vertex and y vertex, we found x vertex and y vertex, and we know that this has to be true as well. So we substitute. So x vertex, which is equal to a over 2. So a over 2 squared. You know what? I'm just gonna rewrite it here. So we know that x vertex squared plus y vertex squared has to equal to 25. Therefore, a over 2 squared plus y squared. Well, this is something I wouldn't want to do, because if I put this in, it's gonna be a to the power 4, something I really don't want. Let's see if there's another way. Because if I put minus a squared over 4 plus 5 squared, that's going to be to the power of 4. I want to avoid these situations because like nothing good ever starts with let's find the 4th power of something equal to 25. So I'm just gonna pause here for a bit and like, I don't like that. let's see if I can do something about it. So I'm going back to these expressions, and I'm saying, look, okay, this is x vertex, and this is y vertex. Well, you can see that actually this can be written as minus a over 2 squared plus 5. And what's a over 2? It's here. Yeah, so in fact, this can be written as minus x vertex squared plus 5. And now back to this. We know that x, so from here, we can say that x vertex squared is equal to 5 minus y vertex. I'm rearranging this expression. So because I know that this is y vertex, and what I'm doing is taking 5 to the right hand side, multiplying by -1, or whichever way you like it. Basically, I'm making x vertex squared the subject, and I'm going to put that into here. And let's see, I have 5 minus y vertex plus y vertex squared equals 25. And that's a quadratic equation. Not too bad, and it's not too bad of a quadratic equation. So y vertex squared minus y vertex minus 20 equals 0. So using Vietta's formula here, so y1, y2 is equal to minus 20. y1 plus y2 is equal to 1. So two numbers add to 1, multiply to minus 20. That's y vertex is either 5 or y vertex is minus 4. And y vertex. And we know Samuel, you're confusing the factorization and Vietta's formulae. Okay, I did say last week that it's going to be confusing sometimes, but I mean, you can choose not to use Vietta's formulae, and I mean, that's not the end of the world. And so these are the two possibilities. But remember, we were looking for A. We weren't. So your natural instinct here would be to find X vertex, and I mean, you can do it, but then well, actually, yeah, let's do it because that way we'll find A much easier. Okay, so we found if Y vertex is 5, we can find X vertex. X vertex is 5 minus Y vertex. So in this case, X vertex is 0. Or X vertex is going to be 5 minus 4, so 9. So x squared is 9, so x is plus or minus 3. So there are 3 possibilities, and we know that x vertex is a over 2. So a is 2x vertex. So the possibilities are a is 0, a2 is minus 6, and a3 is 6. Okay. Now this is the proper way of doing it, the algebraic way, and probably the only way you could do it when I was your age. But now we have this. We have a graphing calculator, and this is the. So what I'm going to do is I'm going to draw the parabola, and this is A. So I've added a slider for A, and look what happens when I change A. When I change A, the parabola shifts. Parabola shifts. So I change A, and that causes the parabola to change. And at some point, it will be a few points. It will. So for example, when A is 6, when A is 6, they tell me that it is a distance of 5 away. Well, that's 3 and that's 4. Oh, it is. And then when it's 0, and when A is -6. That looks very accurate. To emphasize, well, a 5 away from the origin. Well, that's a circle, isn't it? That's a circle of radius 5. So let's see what happens when A is 0. A is 0. Yeah, the vertex is on the circumference. Let's see. When A is 0, x is 0, y is 5. Let's see. When A is 0, x is 0, y is 5. Absolutely. And if I make y equal to 6, you can see once again that the vertex is on the circle, and the coordinate is 3 minus 4. And when A is -6, and it's -3 minus 4. Exactly. And that's what they were asking. They were asking here. Well, I was asking. It's 5 units away. Find the locus of the points drawn by the vertex as A changes. Find the locus. And you might have noticed, like, look what happens if I just move. It looks as if it is a parabola, and it's parabola with a vertex at 5. So the easiest parabola we can come up with is y equals 5 minus x squared. Let's see if that is true. Oh, that looks magnificent. It was a guess, but it was an educated guess. You can see that actually the red parabola moves along. The vertex of the red parabola moves along this parabola. So the locus of the points traced out by the vertex is another parabola. And it's part of the question. But let's see why it happens. Oh, actually here it is. From here, I can say that y vertex is equal to 5 minus x vertex squared. So it is. This is the locus of the points traced by the vertex of the parabola. You can add a sketch. Okay. Right. So I advise you to use graphical methods whenever possible. Okay, especially if you have if for A levels you're using your fancy calculators like this one. Oh, Casio one, sorry. It's the same for IB. Yeah, for IB use one of those. I guess TI Inspire. Yeah, I mean, whenever you can use graphical methods, and even if you don't have a calculator, you can still use graphical methods, right? Especially in questions like this, like you need to the vertex move along minus x squared plus 5. Yes, that is correct. And you can actually do the same on a calculator. If you take the Casio calculator, you can add a slider and change and see what happens. Okay, problem 2. We're kind of starting with difficult ones today. Sorry about that. For all values, find all values of the parameter a where the equation x squared has two distinct positive roots. Okay, so this is a quadratic equation. I mean, we could cheat right away and just draw this in Desmos. So let's see if here's the parabola. It needs to have two positive real distinct roots. Okay, that means it has to cross the x-axis twice, and in both cases the x's have to be positive. So if I move, so when a is 2, it doesn't cross at all. So keep shifting, 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 shifting. Aha. So when a is 4, there is 1 point, so there's one root. And when a is greater than 4, you can see that a is greater than 4. So you can write right away. A is greater than 4. Okay, let's go to the negative side. Okay, both are negative, so that doesn't fit us. And then one is positive, one is negative. So we kind of know the answer right away using this graphical method. Okay. I mean, it would be difficult to do it. It would be difficult to do it manually, but okay, that's certainly is doable. Right. So the answer should be a greater than 4. Let's prove that. So it has two roots. It has two roots. That means the discriminant is positive. So the discriminant is b squared minus 4ac. That's the bit of the quadratic formula you're very well familiar with. You must be. And that's going to be 4a minus 1 squared. So the square of this bit minus 4 times 1 times 2a plus 1, which is c. Yeah, this is c and a is 1. 4 times 1. Okay, we simplify that. 4a. Well, I'm guessing we just expand. 4a squared minus 8a plus 4 minus 8a minus 4. So 4 cancels, and we get 4a squared minus 16, which is equal to 4a minus 4. Okay, so we need to find when this is positive. So this has to be positive. Well, you might not know anything about this. Yeah, you might not know how to solve quadratic inequalities. But you can use common sense. This is a product of two numbers. And the product of two numbers has to be positive. So that means that either both of them are positive or both of them are negative. So that means 4a is positive, a minus 4 is positive, or both of them are negative. 4a is less than 0 and a minus 4 is less than 0. Okay, in this case, so this is 4a greater than 0, so a is greater than 4, and this is a is greater than 4. So a is greater than 4 and a is greater than 0 and a is greater than 4. So overall, this means that a is greater than 4. Or a is less than 0 and a is less than 4. Well, if a is less than 0 and a is less than 4, that means a is less than 0. Okay. All right. So a is greater than 4. Okay. So we look at the two cases. Case 1. A is greater than 4. We have x1 is equal to minus b plus square root of the discriminant. Well, discriminant d. Yeah, just a d. It's just a cursive d. Over to a. So that's minus b, so that's 2 a minus 1 plus square root of that. Square root of 4a minus 4. Okay, it might look confusing, but we don't need to solve much here. Divided by 2a. And x2 is the same thing, but with a minus. Okay. Now let's analyze. Well, if a is greater than 4, this is positive. This is greater than 0. And this is greater than 0. So that's not a problem. So this is greater than 0. Now this one, this is greater than 0. So this is greater than 0. This is greater than 0. And this is greater than 0. So we need that 2a minus 1 has to be greater than square root of 4a minus 4. So in order for this number to be positive, this has to be true. Yeah, absolutely. Factorization doesn't. Or a squared minus 16a, which is the same thing. Does this make sense? This logic that this is positive if this is true. Yeah, because then this number minus this. Am I explaining it well enough? Do you understand? Please let me know. Let me know if you're confused. Over 2. Yes, of course. Yeah, 2a has nothing to do with it. Sorry. That is my bad. it is confusing when you use the formula and the parameter. Maybe use p as a parameter. I'll try to do this next time. Okay, so if this is greater than 0 if this is true. So if this number is greater than this number, if you would write in the format x such that x greater than y. No, just x greater than y. So no need of extra symbols. So we square this. This is going to be 4 a squared minus 2a minus 1 greater than 4a squared minus 16. So I'm squaring both sides, and then 4a squared minus 8a minus 4 greater than 4a squared minus 16. And we have 8a minus 12 is sorry, that doesn't make any sense. Minus 16a, yes. Sorry. Yeah, okay. Minus 16a, thank you. And this is going to be 8a greater than 4. So a is greater than half. But a is already greater than 4. A is already greater than 4. So therefore, this will also true. This is true. Yeah, because we are looking only at a is greater than 4. This is true. So it will have, for any value, of a greater than 4, the equation will have 2 positive distinct roots. And case 2, we're looking at case 2. Just changing that, case 2. Case 2. A is less than 0. If a is less than 0, then x1 is 2a minus 1 plus square root of 4a plus minus 4 over 2, and x2 is 2a minus 1 minus 4a minus 4 divided by 2. And now let's analyze what we have. Well, this is a negative number because it's minus square root, so that's negative. And this, because a is less than 0, a minus 1 is a negative number. So this is negative. So negative and negative, this will always be negative. So for x2 is negative, when a is less than 0. X2 is negative when a is 0. So it doesn't fit. We need two positive distinct roots, and therefore none of the values of a less than 0 suit us. That's it. So the answer is a is greater than 4. Greater than 4. And we kind of saw that from the very beginning, remember? So a is 10, a is 6, a is 5, a is 4. So a is 4 is not suitable, but anything greater than 4 is. So 4.1. Now we go back, and when a is 0, a is 0 now. But then when we go negative, we see that one of the roots is always negative. It's always negative, and you can do nothing. There's nothing you can do about it. So we don't care about the other one. We don't care about the other one because the x2 will always be. So this is. I'm gonna paste that. So this is a is less than 0. This is x2. This is x2, which is always less than 0, so not suitable. And make it a. Put it somewhere here. So here we have x1. X1 is just positive, and x2 is here, and x2 is greater than 0, and x1 is greater than 0. Okay. I can't read the first number under the square root on x2. Oh, that's 4. I mean, it's the same. It's a 4. It's the same. It's the same. Just right here. By the way, you can always look at the board at any time, day or night. I know. Wake up in the middle of the night, you want to see. Okay, the rest of the questions are easier. Okay, I think I've managed to put the hardest questions at the top, at the front, and now we're doing easier questions. Okay, another question. Oh, sorry, I accidentally sent that to. I sent the board to just one person. Okay, so for which values of m is exactly one root equal to 0? So we have an equation. We have a parameter again. And we also have a modulus here. Okay, we will have a separate assignment on modulus. Okay, but here we'll try to figure it out. We'll try to figure it out what it says. For which values of m is exactly one of the roots is equal to 0? Well, if one of the roots, if x equals 0 is a root, is a root, what can we do? What does this imply? If x equals 0 is a root, help me please. You can use your voice or you can use the chat. No. It could have 1, 2, 3 roots. Then we can factorize out x. I don't see how you can Ben Bevan, almost true. Very close. No, not. If x equals 0 is a root, yes, like Sanan, you can substitute 0 to x to find m, of course. Then sub x equals 0 into the equation. All right, so 0 squared plus m plus 3 times 0 plus modulus m minus 3 equals 0. This is 0, this is 0. So we have modulus m minus 3 equals 0. So modulus m equals 3. Now, modulus, like, you don't need to know much about the modulus. Type 0, please, if you have never heard about modulus. If you've never heard modulus or absolute value, oh, okay, so quite a few of you. If you have never heard about it, yes, you've never heard about the absolute value. Absolute value. Okay, modulus and absolute value are the same thing. I'm happy to explain that. So the modulus tells you modulus x is the distance from x to 0. X to 0 on a number line. On a number line. So if you have a number x, a number x, and you have a number 0, well, this is 0, this is the beginning. You have this distance is called modulus x. Okay. So if the number is 7, this is modulus 7. Okay. So what is modulus 7? Okay, it's 7. And what is modulus? So this is minus 5. And this is modulus minus 5. Minus 5 is 5. Well done. Okay. So modulus of a number is 3. So there are two possibilities. Either the number is 3 or the number is minus 3. Because modulus 3 is 3 and modulus minus 3 is also 3. Okay. In a way, this equation is very similar to m squared. So compare to m squared equals 9. And you get m equals plus or minus 3. Okay, so in a way, this is similar. I'll cross this out just not to confuse anyone. But All right. Now we got two answers, but is that enough? Is there a difference between plus minus and modulus x? Yes, because plus minus, let's say, yeah, plus very Ahmed. That is a fantastic answer, Ahmed. Like 10 points to Gryffindor, because the modulus only gives you one value, whereas plus minus gives you two values usually, unless it's 0. Um, I don't know if you wanted if well, okay. Anyways, like plus or minus 3, for example, is two different values, whereas modulus is always only one value. So hope that makes sense. Okay. Right. Now, is that enough? Is that have we so we find two different values. They cannot both be 0, of course. So we need to check that. We need to check that both of them are not 0. So what we do is we only have two values. So we produce a sanity check. So sanity check. So let's say m is 3. So we have x squared plus 6x plus 3 minus 3 equals 0. 3 minus 3 cancel out. X, and we can factor it. So x and x plus 6 equals 0. So x1 is 0. x2 is minus 6. So m minus 3 is good. Good. And let's say, let's check m equals minus 3. Equals minus 3. So we got x squared. Now, minus 3 plus 3, that's 0. Plus 0x. Plus modulus minus 3 minus 3 equals 0. So we got 0. 3 minus 3 is 0. So we're going to x squared equals 0. So we only have x1 is 0 and x2 is 0. You can say x is equal to plus or minus 0 in this case. So yeah, it's not. So not good. Not good. Not good. So the answer is 3. X equals, so m equals 3. M equals 3. You see how like all these problems, and I kind of try to find problems like this or invent them sometimes. Right. This is like a sort of, you have to use your imagination. You have to use, this is an artistic process. Yes, like one very famous mathematician once said that his friend who he went to school with became a poet because he did not have the imagination to become a mathematician. Right, because it is, you kind of you have to see what's this. You can, there's always like 10 different ways of doing the same thing, and you kind of find the best way. That's why I'm showing you all these tricks, like graphical methods, then just looking at the number and seeing what's in front of you, and you're trying to analyze. Right. How much time do we have? Okay, not bad. We've got 40 minutes left. X1 and X2 are roots of the equation. Write a quadratic equation whose roots are. I had this question in the assignment, but then I decided to delete it. But nevertheless, I'd like to show you how to do this, because this is a very common problem. And if you do further maths, you will encounter these problems very soon. Okay, write a quadratic equation whose roots are x1 minus 2 and x2 minus 2. So let's start with the equation. X squared minus 7x minus 3 equals 0. Applying the Vieta's formulae, which is in the assignment, so x1, x2 is minus 3 over 2. x1 plus x2 is 7 over 2. Okay, so we've established this. We don't need to solve the quadratic equation. We don't need to find x1 and x2 because they're not pretty. Okay, now we need a quadratic equation whose roots are x1 minus 2 and x2 minus 2. So we know that x1 minus 2 multiply by x2 minus 2 well, let me try to explain what I'm trying to get at. We'll have x alpha 1, alpha 2. Let's just label them. Alpha 1 and alpha 2 are the roots. We'll have a quadratic equation we'll have A, B, and C. And we know that alpha 1 multiplied by alpha 2 will equal to plus C over A. And alpha 1 plus alpha 2 will be equal to minus B over A. So these are the numbers B, C, and A. So we're looking for a quadratic equation. So we need to find C over A, we need to do this. So this would give us C over A. C over A of the future equation is this. And if we expand this, it's going to be x1, x2 minus 2x1 minus 2x2 plus 4. And it's going to be x1, x2 minus 2 x1 plus x2 plus 4. And as a matter of fact, we can find this quite easily. x1, x2, we already know that. It's minus 3 over 2. Minus 2 multiplied by 7 over 2 plus 4. So that's minus 3 over 2. Minus 7 plus 4, that's minus 3. And minus 3, so it's minus 6, minus 9 over 2. Minus 9 over 2. Now, minus B over A, the second bit, is alpha 1 plus alpha 2. So the roots. So there's going to be x1 minus 2 plus x2 minus 2. And this is going to be x1 plus x2 minus 4. So x1 plus x2 is 7 over 2. 7 over 2 minus 4. And that's minus a half. And here we are. We have C over A equals to minus 9 over 2. We have minus B over A, which is a half. Or you can simply say okay. Now, one thing you need to understand that if you divide the equation by A, nothing changes. Okay, if you divide the equation by A, it becomes x squared plus B over A x plus C over A equals 0. It's the same equation, just written differently. And here we are. C over A is minus 9 over 2. So that's minus. So I'm going to use that here. Minus 9 over 2. B over A is a half. So plus a half x and x squared. And that's equal to 0. And then we just multiply the whole thing by 2. We get 2x squared plus x minus 9 equals 0. Okay, so we started with the Vieta's formulae, and then we needed to find a quadratic equation. This is the quadratic equation we're looking for. And we know that the product of the roots is C over A, and the sum of the roots is that. And we find the product of the roots. Here it is, and it's 9 over 2. We find the sum of the roots is minus a half. We substitute that into this equation, and we get the final equation. On a scale of minus B over A is minus a half. Sorry, minus B over A is minus a half. I've made some typo. And so that means B over A is a half. Now, on a scale of 1 to 10, how well do you understand this problem? Don't be shy. Thank you. Yeah. Using graphic, this makes it easy. But 6, 7, right. Okay. Right. If you still have questions after the lesson, do ask me. Do ask me at the end. Now, what if I said that, well, there's another way of doing the same thing? Well, because if you notice that these roots have the same method of, well, it's the same roots minus 2. It looks like we can do a substitution. W minus W is equal to x minus 2. Okay. And from here, I can say that x is equal to W minus W plus 2. W plus 2. And all I need to do is substitute that into the equation. So 2 multiplied by W plus 2 squared minus 7 w plus 2 minus 3 equals 0. We expand this to w squared plus w plus 2, so that's 8. 8w plus 4. Oh, not 4, sorry, that's 4 times 2, 8. Minus 7w minus 14. Sorry, 14 minus 3 equals 0. 2w squared. 8w minus 7w is plus w. 8 minus 3 is 5. 5 minus 14 is minus 9 equals 0. Ooh, a familiar thing, isn't it? A familiar equation. Okay. I'd say the second method is slightly easier. You might disagree with me. Method 2. So what am I on about? You need to be able to find a quadratic equation with given roots. And you can use the Vieta's formulae for that. Okay, so the Vieta's formula, the sum of the roots is minus b over a. So you know the coefficients, and the product of the roots is that. I won't do the rest. I think you can. You can do the rest. Can you switch off the cameras, please? Because last time we had an issue that cameras are on the recording and they shouldn't be. Okay. That's Ben Bevan. Can you switch off your camera, please? Thank you. Right. Problem 5. Actually, before problem 5, I'll switch those two problems. This is the same problem, but much easier. Problem 5. Write down a quadratic equation with given roots. Okay, so we do the same thing. We have x1, x2 is square root of 15, and x1 plus x2 is square root of 3 plus square root of 5. And that is equal to minus to c over a, and this is equal to minus b over a. And we have a squared, whoa, you did not see that, ax squared plus bx plus c equals 0. We divide by a, so x squared plus b over a, x plus c over a equals 0. So x squared plus b over a, so that's going to be minus plus square root of 5x plus c over a, which is square root of 15. And that's the quadratic equation we're looking for. Super easy, right? But what if I said if you can do it even easier? Because if you're given two roots, x1 equals square root of 3 and x2 equals square root of 5, you can do it like this: x minus x1, x minus x2 equals 0. So x minus square root of 3 x minus square root of 5 equals 0. And then you can do x squared minus square root of 5x minus square root of 3x plus square root of 15 equals 0. So x squared minus square root of 5 plus square root of 3x plus square root of 15, 0. Okay. In general, if you have an equation with two given roots, let's say x1 is equal to 3 and x2 is equal to 2, that's super easy. X minus 3, x minus 2 equals 0. X squared minus 3x minus 2x plus 6 equals 0. X squared minus 5x plus 6 equals 0. This is the equation with two given roots. And it always works. It always works. It's just sometimes not easy to do. Sometimes not easy to do. And let's look at B. Now, so this is problem A, and this is B. And so x one is equal to 3 minus square root of 5. X2 equals 3 plus square root of 5. Okay, so you can find the product. You can find, so there's two ways that you already know, which I've shown you. But there's also another way of doing it. So you can do x1, x2, and x1 plus x2. That would give you the answer. Or, so method 1, method 2, you can do x minus 3 plus square root of 5, x minus 3 minus square root of 5. And if you expand that, you'll get a quadratic equation. But there's a third method, which is probably the most elegant. So here I'm using x minus x1, x minus x2 equals 0. I'm using this method here. Here I'm using vietas, and so it's called the inverse completing the square. Completing the square. The square. Right, so we have x is equal to 3 plus or minus square root of 5. Okay. This is, so x is 3 plus or minus square root of 5. We're going to take 3 to the left-hand side. X minus 3 equals plus or minus square root of 5. Now we square both sides. X minus 3 squared equals 5. Now we expand. X squared minus 6x plus 9 equals 5. X squared minus 6x plus 4 equals 0. It is. I mean, it is. I love this method. It doesn't always work, but it works very well when you have plus or minus square root. And So it's the inverse process of completing the square. Okay. Do practice, like do practice. Find a quadratic equation with roots 2 plus minus square root 7, 2 plus minus square root 17, and just give it a go, and it works out. It works out very nicely. Okay. Problem 7, problem 8. Okay, problem 6. For which values of a does the equation have 3 distinct roots? And well, okay. Can I do the second method? Yes, sure. Sorry, let's go back to this. I've got a request to do the second method. Okay, so you expand this. Well, and it's just step by step. Okay, so x times x times 3. So x squared, I'm multiplying. So x minus 3x minus root 5x, then minus 3x plus 9. So I'm multiplying each by each. And then 3 minus, so plus 3 root 5. And then root 5x plus root 5x, then minus 3 root 5, and then plus 5. Yeah, because 5 and 5 plus 5 equals 0. And then 3 root 5 minus 3 root 5, root 5x and root 5x. And we have x squared, 3 and 3, so minus 6x. And we have 9 plus, sorry, it's minus 5, of course. It's minus 5 because it's plus root 5 minus root 5. So that's going to be plus 4 equals 0. Yes, Samuel, thank you. And okay, and let's do the first method as well. Why not? Vieta's formula. Find the product. We find the product is 3 times 3, so that's 9. So we are multiplying this by that, multiplying 3 by that. So plus 3 root 5, then minus 5 times 3 minus 3 root 5, and then minus 5. So that's equal to 4. And x1 plus x2. So we just add them, and you can see the square root cancels, and we got 6. And we know that x squared plus b over a x plus c over a is 0. So that is v over a. So x squared minus 6x plus 4 equals 0. Okay, same equation. Okay, that does that help? Okay. For which values does the equation have 3 distinct roots? And why not just do it on Desmos again? Like here it is. I've prepared it for you. Here's the formula. So y is equal to the left-hand side of the equation. Y is equal to the left-hand side of the equation. So y is equal to that. Okay. And we change a. Right now it has four roots. Keep increasing. It looks like it's going to have 4 roots. So we're looking for something interesting to happen. So we reduce a until we get, well, that's still 4. That's not helpful at all. And that's 2 roots. So there's no in between. There's 4 or 2. There's no 3. At no point is it 3. So we keep reducing. Oh. Aha. That's 3. So when a is -1, that's one of the solutions. When a is -1, and then it's 2 equations, and then okay, so that's 0, 0, 0, 0, 0, 0, 0, 1, then 2, and it looks like only at when a is -1. It looks like the only way. This is not a valid method for an examination, and not a valid method for COMPOS either. You can't justify your answer saying that, oh, I've drawn that on a calculator and that's the solution. No, you need to explain your solution. It helps to so we know that we're looking for what we're looking for, but you can't use that. All right. So let's see what we can do. So this is a product of 2. I definitely don't want to factorize it, but what I want to do is look at the 2 separately. So got a plus 4x minus x squared minus 1. So either that is equal to 0, or because it's a product of 2 numbers, yeah, so a times b is 0. That means a is 0 or b is 0. A plus 1 minus x minus 2 equals 0. So this is a quadratic equation. So we're finding the discriminant. Discriminant is b squared. Well, it's better if we write the equation. Write the equation first. So it's going to be x squared minus 4x plus 1 minus a equals 0. So the discriminant is 16 minus 4 times 1 minus a, and that is equal to 16 minus 4, that's 12 minus 4a plus 4a, and we take 4 out, a plus 3. Why negative x squared? X squared, I've changed the signs. And so if a is less than -3, we have 0 roots. If a is equal to -3, we have 1 root. And if a is greater than -3, we have 2 roots. Right. So here we have x minus 2 modulus is equal to a plus 1. Now, this is a modulus, and a modulus is always positive. So if this thing is negative, so if a is less than -1, it has 0 roots. If a is -1, it has 1 root. And if a is greater than -1, it has 2 roots. Okay. there's one thing. So from here, you can already see. Okay, so in order for them to have 3 solutions, you need to have 1 solution and 2 solutions. And the only place where it is possible, it is where a equals to -1. It has 1 root here, and it has 2 roots here. So when a is -1, as long as you don't have equal roots. So as long as you don't have equal roots. And what can you do here? Well, I would actually try to find the roots. So here, x1, x2, x12 is equal to minus b, so 4, plus or minus square root of 4, a plus 3, and plus or minus over 2. And here, so here, so x minus 2 is equal to plus or minus a minus 1, a plus 1, sorry. So x is equal to 2 plus or minus a plus 1. So here, I can simplify this. I can simplify this as 2 plus or minus, and then 4 and 2 cancel out, square root of a plus 3. And as long as this bit is not equal to this bit, we are good to go. Because look, what I'm trying to find is it's easy to say, well, we have 2 roots here and 1 root here, and that means we have 3 distinct roots. But what if why is it for a? Where is that? It's 12 plus 4a, which is 4, a plus 3. I factorized it. Hope that makes sense. So as long as this bit is not equal to this bit, the roots will not match up. Yeah, so these 2 are different, these 2 are different, and these 2 are different. And as long as these 2 are not the same, we will have different roots. So let's find when they are equal. So a plus 3 is equal to a plus 1. So a plus 3, I square both sides, is equal to a squared minus 2a plus 1. And a squared minus 3a minus 2 is equal to 0. A squared. So they're only equal in, are they equal? 1 minus 3 minus 2. When a is 3.5 and 3 minus square root 17. Well, it is plus, yes. So it's plus a. Sorry, making mistakes today. So a equals 1. A equals minus 2. So 1, 1, minus 2. Yeah, 1 and minus 2. So a is 1 and a is minus 2. So these are the two that we need to check. So when a is 1, when a is 1, but they both match up. Look, when a is 1, they both match up. So it's still 2. And when a is minus 2, when a is minus 2, they both match up again, but and even here it just doesn't really make sense. It's still 2. So when a is minus 2, so it's going to be 2, and yeah, that's that's it. We have we've eliminated these options, so no and no. So therefore, the only solution, the answer, is a is minus 1. Okay, hope that makes sense. And just two more. Solve for all values of a. Now, like, despite that it being that it looks difficult, it's actually very easy. So solve for all values of a. So here, first of all, there's a fraction, and a fraction is equal to 0. A fraction is equal to 0 when the numerator is 0 and when the denominator is not 0. Okay, so the numerator is 0, the denominator is 0. So let's do the denominator first. So 3x squared minus 7x plus 2 is not equal to 0 because you can't divide by 0. There's only one person in the world that can divide by 0. If you know his name, write it in the chat. If you're not him, you cannot divide by 0. And now, not Siri, no. Not a person, it has to be a real person. Then, okay, so and here you just solve it. And when you solve it, you can choose whichever way you like. I won't bother you with solving a quadratic equation. Will I? Okay, I'm going to use the quadratic formula. X1, X2. Sorry, Vietta's formula. X1, X2 is equal to 2/3, and X1, X plus X2 is 7/3. So we have two numbers which multiply to 2/3 and add to 7/3, and the numbers are 2 and 1/3. 2 and 1/3. Yes, because 2 plus 1/3 is 7/3, and 2 times 1/3 is 2/3. Okay, so this is how you use Vietta's formula to solve quadratic equations, even tricky ones. Oh, of course, I mean x is not equal to 2, and x is not equal to 1/3. And this is important. We will remember this. And now we go to the second equation. So we have x squared minus a plus 1, x plus 2a minus 2 equals 0. So we'll find the discriminant. Discriminant is b squared, so a plus 1 squared minus 4 times a times c, so 2a minus 2. I like to do the discriminant separately from the formula because it looks much neater, especially when you have parameters. It's going to be a squared plus 2a plus, sorry, 2a plus 1 minus 8 a plus 8, which is a squared minus 6a plus 9, which is a minus 3 squared. A minus 3 squared. And now you have x1 is equal to a plus 1 minus a minus 3 divided by 2, which is a minus a 0, 1 plus 3, so that's 2. And x2 is equal to a plus 1 plus a minus 3 divided by 2, which is equal to a plus a, so that's minus 2 over 2, which is minus 1. What? Sorry. 2a. So it's a minus 1. Okay, yes, that makes more sense. A minus 1. Now, we are happy with this as long, it says the first solution is 2, but x is not equal to 2. So this is rubbish. Yeah, we don't need that. It's not equal to 1/3. So we have to see that a minus 1 is not equal to 2, and a minus 1 is not equal to 1/3. So a is not equal to 3, and a is not equal to 4/3. 4/3. So the answer to this question, so x equals 2 is not a solution. So x equals a minus 1, but a is any number except 3, and a is not equal to 4/3. This is the kind of answer you need to give to the problem which is in the assignment, which is very similar to the one, in the assignment. How well do you understand problem 7? Please let me know. 11, or is that 1 and 1? Okay, very nice. Okay, very good, very good. Yeah, and it's a neat equation and quite a neat solution. I'd say it's way easier than the previous one. Okay, and the last one is, I'd say, the easiest one of today's. It doesn't look easy, but actually it is. All you need to do is you need substitution. Substitution, u is 5x plus 1 over 2x minus 3 squared. Now, these are very similar, but instead of 2x minus 3, you have 3 minus 2x. But because it's a square, it doesn't make any difference. I won't get a good, we're running out of time. I won't get too deep into that. But you have u square, sorry, there's no square, u plus 1 over u equals 82 over 9. You multiply by 9u, so 9u squared minus 82u plus 9 equals 0. You have u1 using Vietta's formula. U2 is c over a, so 9 over 9. 9 over 9, which is 1. And u1 plus u2 is 82 over 9. Now from here, it's quite easy to guess that u1 is 1/9, and u2 is 9. So from here, you get 5x plus 1 over 2x minus 3 squared is 9, and 5x plus 1 over 2x minus 3 squared is 1/9. And you kind of end up with 4 equations. So 5x plus 1 over 2x minus 3. So equals to 3, equals to minus 3, equals to a third, and equal to minus a third. And then you just you find these are linear equations. Actually, they don't look linear, but you just multiply by 2x minus 3 both sides. So 5x plus 1 equals 3, 2x minus 3, and you find x. Okay, so looks scary, but actually it's not. It's quite straightforward. All right, that's it for today. Hope you found this useful. I did go through some questions which are very similar. If you have any questions. Oh. Oh. Okay. Old beam. Okay. You're welcome. Welcome. See you. Okay. Happy birthday. All right. Welcome. See you. You don't have to take further maths, but it does help. I mean, it's not a requirement because every assignment we will give you the material. But if you don't take further maths, it will take you more time to go through the material. So it's up to you. Yeah, it's not. We don't have any requirements. As long as you can do the assignments, as long as you attend your tutorials, it's fine with us. But you might find it difficult. So just letting you know.